All right, my name is Brandon Clayton, the Algebra Guy. Today, I will be discussing with you multiplying and dividing mixed numbers step by step. So we'll go through and talk about what the steps are, and I want to give you about 4 problems that we can work through together to give you a good idea of how to go through these. So let's do it. And as usual, let's start off the way we always start off with our questions. So what are the questions we want to answer? This is going to be pretty simple because we only got one. There's really only one thing I'm after today is how do I multiply and divide mixed numbers? So without further ado, let's jump into it and start to that process. 3 steps. Convert the mixed number. So let me highlight some important parts here. Don't want to go there yet. So let me highlight some important pieces. We're going to convert this mixed number to an improper fraction. So we actually want it to be improper. If you remember in some lessons before, we actually tried to get a mixed number to an improper, and I told you that it would be helpful later on because when you're multiplying and dividing these numbers, it's a lot easier to work with. Adding and subtracting can be the same way too, but particularly multiplying and dividing. All right, so follow the rules for fraction for multiplication and division of a fraction after you've done that, and then we're going to simplify. So as you just saw, I have a few problems I want to go over just to make sure we get this right. So what I would encourage you to do at this point is pause it here and see if you can work this. What would you come up with if you were to do this problem? See what you would get. So all right, so let me work this according to our step plan. And the first thing we do is convert the mixed number. Actually, you know what? The first thing I think some of us may have done is we're just going to instinctively take the whole numbers and multiply those. And that's going to give us -2. And then we're going to multiply using the fraction rules for multiplication, which is numerator times numerator. So 4 times 7, so that'd be 28. And 5 times 8 is 40. We want our answer simplified, so -2. Now, honestly, I don't know if this is going to work. I haven't tried it this way, but I'm thinking that if someone were to just take this and try it from what we've talked about to this point, you might do this. So let's see if this works. So let me see. This can be simplified. I can take out a 4 from the top and bottom. So that'll be a 7 here and a 10. So 2 and 7/10. So let's work it out the way that we're asked to work it out here. First, we're going to convert these both to a mixed number. To do that, we take the whole number, multiply it by the denominator. I'm going to erase some of this. We're going to multiply by the denominator, then add the numerator. So 2 times 5 is 10, plus 4 is 14 over 5. And again, if you struggle with what am I doing and need some more practice, please go back to a previous video about taking mixed numbers to improper fractions. All right, so same thing for this one. We're going to do 1 times 8 is 8 plus 7. And that's going to give us 15. Notice I ignored the negative on that 1 because that'll really throw my numbers off. So I want 1 times 8 and I don't want -1 times 8. So just 1 times 8 plus 7. And then we're going to do that there. Now we can multiply going straight across. I don't want to multiply 14 times 15. You can if you want to. It's going to give you the same thing. But I want to go ahead and start to break this into prime numbers so that we can simplify pretty easily by crossing out the like terms that we see on the numerator and the denominator, or the like factors. So instead of writing 14, I'm going to go ahead and just write, let me get my line ready. And my negative, I don't want to forget because I know this is going to be a negative times a positive. It's going to give me a negative answer. So I'm going to write 14 as 7 times 2. And I'm going to write 15 as 3 times 5. So that makes this so much easier than getting this really big number and trying to break it down later. So I'm just going to do it now. And then down here, I'm just going to do 5 times 8. But instead of 8, let's break it into 2 times 2 times 2. Because 2 times 4 is 8. 2 times 2 is 4. 4 times 2 is 8. So these 3 2's multiplied together make up the 8. So we got the same thing. I just broke it down so it's easier to simplify. And now I'm looking at the top and bottom, and I see we have 5's that can cancel out, and we have a set of 2's that can cancel out, but I don't see anything else. So when I write this, I know I'm going to have a negative. Let's do a different color. I'm going to stick with, I'll do it light blue. So I'm going to have a negative 7 times 3 is 21, and 2 times 2 is 4. So negative 21 over 4. Now, I'm comparing it to the original answer that I would have gotten had I not done it properly. So if you would have just went through here and just said, well, I think I'm going to multiply my whole numbers and then I'll multiply my fractions, you would have gotten this. And that's not giving us the right answer. So actually, this is our answer. This answer is, if we put it in a mixed number, and we can leave it this way, it's simplified. There's nothing else I can do to it. But if I put it in a mixed number, it'll be 21 divided by 4. That goes into there 5 times. 5 times 4 is 20. It should be minus right there. So that ends up giving me the same thing as 5 and 1 over 4. So this is negative 2. Oh, I'm sorry, this is negative 5. So negative 2 and 7/10. This is negative 5 and 1/4. Huge difference. So please don't do that. We're going to follow this step by step and change this to an improper fraction first, then multiply straight across. So that's why that's important. All right, let's go to the next one. And I would encourage you, again, to do this problem on your own before I do it with you. So I will pause it here and try to work this before watching the answer. Okay, so first thing we do, again, is convert the mixed numbers. We only have 1 this time to improper fraction. To do that, we do 3 times 3 plus 1. Well, 3 times 3 is 9 plus 1 is 10. And we keep our denominator, and we're still multiplying 5 over 8. So that's already a proper fraction. We don't have to do anything to that one. And now we can just multiply straight across. 10 times 5 and 3 times 8. 10 times 5 is 50, and 3 times 8 is 24. But you see what happened is that these numbers are kind of big, and I know they can be simplified. So normally I would have just went ahead and broke those down into smaller terms. I would have taken this 10 and broken it down to 5 and 2 and left it 5 here, because now I'm going to have to do that, so that's an extra step. But that's okay, because I wanted you to see what I was doing to save time earlier. And the same thing here, I could have went ahead and broke 8 down into 2 times 2 times 2. So let's go ahead and do that here. I want to change colors. We're going to break this into 5 times 2 times 5. And what did I think of it that way? Because 10 is 5 times 2 and 5 is just 5. So I can't, they have no other factors I can break it into other than 1 time. These are all prime numbers, is what I'm saying. And for the denominator, we got 3 and then 2 times 2 times 2. All right, so anything can I cross out? Yeah, I have a 2 and a 2 on top. That goes away. But I don't have anything else that I can cross out. Not that I can see right now, at least. So I'm going to do 5 times 5 is 25. Because that's all I have up here is 5 and 5. And down here I have 3 times 2 is 6. 6 times 2 is 12. Right there, 25 over 12 is simplified because they have no other common factors by which we can cancel out. Because the only factors for 25 is 1 times 25 and then 5. There's no other. So for 12, there's others, 4, 3, 12, and 1, 2, and 6, but none of them are the same as 25. So this is as good as it gets. Now, if they asked us, or if you needed to know what this was as a mixed number, we could do that math, right? We can just go ahead and divide 25 divided by 12. It goes in there twice. 2 times 12 is 24. 1 left over. So I can see there's going to be 2 and 1 12th. So if I needed to know, like say for instance, you got this number and they asked, well, how many cups of sugar should be added? Well, 25 12ths. Well, that's kind of tough to think about. What does that look like? Well, you can divide and get 2 cups and 1/12 of a cup. That's a little bit easier to work with. So that's when that would be useful. All right, again, pause and I will work this one, please. We're going to go through those same steps again and convert this to a mixed number, the mixed number to an improper fraction, rather. 3 times 7 is 21 plus 4 is 25. And that's still going to be over 7. divided by 5. Now, when we divide by a whole number, it's much easier to change that whole number 5 into a fraction by dividing by 1. So it's already divided by 1 in a sense because it is still going to equal 5. So just putting divided by 1 doesn't change anything. It just makes it easier for us visually to see what's going on. All right, now we just have to remember our rules for dividing fractions. So to divide a fraction, we keep the first term, which is 25 over 7. And we multiply, so we change the division to multiplication, and we do the reciprocal. What is the reciprocal again? Well, the reciprocal is where we switch the numerator with the denominator. I was resisting the temptation to say flipped. I want to try to use more mathematical language while we're doing this, and I want to encourage you to do so that when you do see it on a test or in conversations, you can speak about it academically. So that's 1 over 5. Now we can employ our multiplication rules, which simply tells us when you're multiplying fractions, multiply the numerator with each other. You know what? Before I start writing this out again, I'm actually going to make sure I take it out of my factor. So 25 and 1, that's just going to be 5 times 5 times 1. I'm not going to write times 1 because we don't need to cancel that out. It's just a 1. And then 7 times 5. And there we go. So now it's really easy for me to see what's going to cancel in order for me to get this into simplified form. I can cancel out 5 on top and bottom, and that's going to leave me, let me erase some of this. So that's going to leave me 5 over 7. Don't you hear the music? So now that's how you know it's right. If you hear that music, you know you got it right. So just make the music because I won't be there to do it for you. So 5 over 7 is our answer. Let's do, I believe, one more right here. Try this one, please. Pause it there, and I'm going to go ahead and work it. Let's convert this to a mixed number. So we have a improper fraction. So we have 2 and 1/2. We're going to convert that by saying 2 times 2 is 4 plus 1 is 5 over still the same denominator 2 divided by. We have a mixed number again, need to be converted. 1 times 4 is 4 plus 1 is 5 over 4. Well, we can't divide fractions this way. We need to switch it up here by, let me just say, we need to take this to 5 over 2. We're going to keep the same fraction, change this division to multiplication, and do the reciprocal of 5/4, which is 4 over 5. All right, so now that gives me what? So I'm going to make sure I have an easy time simplifying this by using all my prime numbers. So I got 5, which is prime, and times 4, I could break that to 2 times 2. And I got 2 down here on the bottom and a 5. Can I cross out? Yep, 5s can go, 2 can go. Hey, look at what I got left. So this is just going to equal 2 over 1, and really just 2. 2 divided by 1 is just 2. So all of that, 2 and 1/2 divided by 1/4, 1 and 1/4 is equal to 2. So what that's saying is that there's 2 1 and 1/4 to make up 2 and 1/2. All right, guys, I hope you found that helpful. We just answered our question, how do you multiply and divide mixed numbers? We talked about those 3 steps, convert them to a improper fraction, and just follow the rules from that point. If you need to multiply, go straight across. If you need to divide, keep the same first term, change the division to multiplication, and multiply. Thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.